Okay, so let's have pH and POH system. Starting with the pH class. So ito yung mini-measure natin sa laboratory. We can either use the litmus paper just to know if the substance is acidic or basic. Or if we want to really know the pH, we may use the pH meter. We may use the pH indicator. I'll talk about indicators later. But in sophisticated laboratories, they really have these electrodes, the pH tester, that will give you the exact pH of a substance. But what is a pH? A pH is a negative logarithm of the hydrogen ion concentration. So to simplify that, pH is just the power of hydrogen. Again, pH means power of hydrogen. And if we're going to compute the pH of a substance, this will be our formula. So, as said a while ago, it's the negative logarithm of the hydrogen ion concentration. Okay? Again, negative log of the hydrogen ion. And take note, since this is inside the bracket, it is the concentration. Okay? Concentration of the hydrogen ion. So wala ni daghang introduction na sample problems kaagad. So what is the pH of a solution that has a hydronium ion concentration of 2 × 10 raised to the power of -9 formal? By the way, it's either hydrogen ion or hydronium ion. Baka malito kayo kasi minsan ang binibigay is hydronium ion. Okay, so remember, this is the hydronium ion. Please copy that. Now, ito yung ating problem. We have here hydronium ion concentration of 2 × 10 raised to the power of -9 formal. Itong letter F dyan is the unit of concentration and we call that formal. Now, let's try to compute. pH is the negative logarithm of hydronium ion concentration. So this is just negative log, and then we will just substitute here the value for the concentration of the hydronium ion. 2 × 10 raised to the power of -9. Class, I have taught you already how to do the exponent in your calculators, ha? So please use that. Diba sabi ko, example 2, you input 2 in your calculator, and then pakipindot yung EXP sa baba. If it is not EXP na nakalagay, it will be times 10 raised to the power of X, and then ilagay nyo na diretso yung -9. Kasi minsan ang ginagawa nyo, gumagamit kayo neto, and you will have different answer for this. Okay? So, what are we going to do with this? Input negative. Do not forget the negative, ha? Negative tapos log. Hanapin nyo yung log in your calculator and then ilagay nyo yung 2 exponent, EXP, and then -9. The answer is, if it's 2 decimal places, what's the answer? It's 8.70. Okay? So this is not really a difficult calculation compared to the other calculations that you have. Again, yung pag-compute ng pH is actually easy. Okay? So again, that's negative log. Input nyo yung negative log. Tapos 2 × 10 raised to the power of -9. Yes, Lauren?
I-round off ko siya, ma'am, kaya naging 8.70.
Yeah. Kasi remember, sabi ko 2 decimal places. Ang nakalagay kasi sa calculator, it's 8.6989. If we round it off to 2 decimal places, hanggang dito siya supposedly. But diba, if in rounding off, you're going to consider the next na digit. So we have 8 here. Since this is more than 5, mag+1 ka dito. Now, since this is 9 already, anong sunod niya? Diba 70? Kaya siya naging 8.70. Okay. Questions or clarifications with this one? Naintindihan yon? Anong gagawin sa calculator? You input the negative and then ang sunod yung pipindutin is yung log. And then, ilagay nyo yung 2, pindutin nyo yung EXP. Kaya ito, depende kasi sa calculator, it's either times 10 raised to the power of x or EXP yung nakalagay. Lagay nyo yung -9 and then equals. Okay? And then you will get this answer. And that is the pH of the solution with the hydronium ion concentration of 2 times 10 raised to the power of -9. So if this is the pH class, well, let's see. Is the solution acidic, basic, or neutral? Again, if this is the pH, is the solution basic, acidic, or neutral? What do you think?
Basic, ma'am.
Okay, very good. It's basic. Okay, kasi it's more than 7. So that's our pambungad kanina, our pH scale. If it's 7, it's neutral. But if it's more than 7, it's basic. Okay, I hope that is clear ha. It's basic. Though hindi naman kasali sa question whether the substance is basic. Tinatanong ko lang. Pero kung isasali sa question, you really have to evaluate ha, depending on the pH na makukuha ninyo. Now, ito baliktad. Consider a solution with a pH value of 6.8. What is the hydronium ion concentration? Okay, so again, our formula pH is equal to negative log of hydronium ion concentration. The given here is the pH. The pH is 6.8. So if you're going to list the given, you have a pH of 6.8, and then the hydronium ion concentration is actually missing. So that is what is asked in the problem. So how are we going to do that in the calculator? Let's have the substitution first of the given. So we have here 6.8 for the pH, and then we are going to have here on the other side the negative logarithm of hydronium ion concentration. What are we going to do? Ang makatama ani exempted sa akong quiz ugma. Charot na. Again, ang makatama sa answer ani automatic perfect sa akong quiz tomorrow. I'll give you 2
Eight
minutes.
times.
I'll give you 2 minutes. What's the answer for this? Isend sa kuha ang answer sa chat. I-ano lang sa kuha, i-personal. Huwag nyo i-everyone. Yung pinakauna lang ha, na makatama. 2 minutes. It's 7:52. Let's end at 7:54 for this. Answer. I want the answer. That's fine. I want the answer. Answer dyan. 1 minute na lang. 7:54 na. End na end. Well, let's see kung sino nakatamaan niya sa inyo ha. End na ha. Tama na sa 7:54. Anyway, may time naman dito sa pag-send ninyo. Okay. Sige. Let's answer this. Now, in answering this class, hindi mo siya pwedeng i-divided by negative log ha. Tinry niya siyang i-divide. Like 6.8 divided by negative log. It will be syntax error. Again, syntax error yan siya. In this case, you are going to do the anti-log or the inverse log. So you have to multiply both sides with the anti-log. Okay, sama nyo na yung negative para mawala na din siya dyan. Para makancel yan, negative log dyan. So ang maiiwan dito is concentration of the hydronium ion. Oh, hindi na nakahabol yung answer ni Cyrus. It's already 7:55. Okay, so how do you do that in the calculator? This is shift log. Pag sinabing anti-log sa calculator class, ang gagawin mo ay shift. Pindutin mo yung shift, hanapin yung shift dyan. Tapos, pindutin nyo yung log. So, shift log, tapos negative. Remember, sinama natin si negative. Negative 6.8. The answer is 2 decimal places, 1.58 times 10 raised to the power of negative 7. Okay, this is the correct answer. Then let's back read. You cannot transfer the log on the other side. I remember sa mathematics class, we only transfer a variable to the other side or to the opposite side if the application is either subtraction or addition. Now, since this is multiplication, hindi mo siya pwedeng i-transfer and then i-change mo yung kanyang sign. Pag meron kayong log class and then you have to get rid of the log, you do the anti-log. And then, how are you going to do the anti-log? Pindutin niyo sa calculator niyo shift tapos log. Tapos, you input the number. But do not forget the negative ha kasi sinali natin siya sa ang tawag dyan, anti-log there on the other side. Oh, tama sana yung answer ni Cyrus, no? Kaya lang na-send niya 7:55 na. Layo. Yeah, going negative ang 6.8. That's it. Again, going negative yung 6.8. Kasi may negative, di ba? Negative log kasi ito, hindi lang siya purely na log. So, isama nyo yung negative on the other side. Gawin nyo siyang anti-log tapos negative 6.8. So, ipindot nyo yung shift tapos log tapos negative and then the number 6.8. That's how you do the anti-log class with the negative. Okay, questions or clarifications? This is how you do it ha. We have an example of computing the pH. Sa pag-compute ng pH, like the previous example, walang problema doon kasi diretso na siya. But in this case, baliktad kasi the pH is given and the hydronium ion concentration is asked in the problem. So it's missing in the problem, so you have to compute that. Now, we are facing the dilemma on how to get rid of the logarithm there. So ito yung gagawin nyo, anti-log. We call this anti-log ha, and how you do that in the calculator. Ulitin ko talaga baka may hindi nakakuha dyan. Pindutin nyo yung shift, and then yung log, and then may negative ito. So lagyan nyo ng negative before the number, before the 6.8. Okay, that's the process of getting the hydronium ion concentration. It's 1.58 times 10 raised to the power of -7. Okay? Well, let's have another example. Let me write the example on the screen now. Yes, Atasha.
Ma'am, ngano naging negative gani ang both sides, ma'am? Ay, tama.
pH is equal to the negative log of the hydronium ion concentration. So may negative talaga siya doon. What else?
Constant naman siya, ma'am, kung ang ginapangayo kay itong ato.
The hydronium ion concentration, yes. May negative talaga yan kasi may negative talaga yung ating equation.
Thank you, ma'am.
Okay. Okay. Again, this one, compute for the hydrogen ion concentration of a solution with a pH of 4.67. You try and then you send to me the answer. Okay, let's see. Kung tama na inyong answer na gisend. Sige. Again, this is our formula. pH is equal to the negative log of the hydrogen ion concentration. Pinalitan ko ha, kanina hydronium ion concentration. This time it's hydrogen ion concentration, but nevertheless, they are the same. So we have here pH is 4.67, and then we have negative log here on the other side. And then let's get rid of this negative log here. We'll do the anti-log. We'll do the anti-log here also. Do not forget, isali yung negative. So cancel the negative log on the other side. What is left is hydrogen ion concentration. So what are we going to do with our calculator? Shift, tapos log, and then negative, what's the number? 4.67. The answer is, we have two decimal places, 2.14 times 10 raised to the power of -5. Okay, again, that's 2.14 times 10 raised to the power of -5. Mali ang pag-round off. Be careful of rounding off also. Pag ang next na digit is more than 5, you add 1. Okay, again, you add 1. Pero pag if it's less than 5, then syempre, as is lang yun. It's 2.14 times 10 raised to the power of negative 5. Tanggalin nyo yung negative dyan. Walang negative except for the exponent. Okay, this is the only negative here. But the answer, class, hindi negative 2.14. It's 2.14 times 10 raised to the power of negative 5. Okay, do you have questions? Before tayo mag-move on. So we have a lot of computations this morning. And you really have to know the formula, ha? So the next one, class, if wala na tayong question, we have the POH. Si POH naman is for the bases kasi this will measure the strength of the base using this formula, negative logarithm of the hydroxide ion concentration. So remember the Arrhenius theory. Arrhenius theory states that if the substance is an acid, it will have hydrogen. So kaya pH kanina. And then if a substance is a base, it will give off hydroxide ion. So again, this is for the bases and we follow this formula. Actually, it's the same thing with the pH, no? POH is equal to the negative logarithm of the hydroxide ion concentration. So you will definitely know whether you are asked to compute for the pH or the POH. Kasi pag sa pH class, ang given dyan, either hydronium ion or the hydrogen ion. Pero pag POH, ang pinapa-compute sa inyo, always yan ang given is the hydroxide ion concentration. Okay? So you will have the same way sa pag-compute nito. Just like this one. What is the POH of a basic solution? Ay, wait lang. Magaling ko na nga lang siya. Okay, so this is the hydroxide ion concentration. 3.7 times 10 raised to the power of negative 3 molar. So what is the POH? Sige daw, you compute what is the POH. .43. Sure na yan? 2.43. Sige daw, POH is equal to the negative log of our 3.7 times 10 raised to the power of negative 3. How are we going to do that in our calculator? Negative tapos log and then 3.7 times 10 raised to the power of negative 3. This is 2.43. So this is our POH. Okay? Sige, tama. 2.43. Bakit may negative yung iba? Ano nawala sa process niyo? Bakit may negative yung answer niyo? Okay, check. Anong nawala? Nakalimutan niyo. May nakalimutan kayo dyan sa process niyo. That is the negative. Nakalimutan niyo ito. Kaya yung answer niyo ay negative din. So be careful. Again, ulitin ko, it's negative tapos log and then 3.7 times 10 raised to the power of negative 3. Okay? What do you mean both may negative sign? May negative ang log, tapos may negative din yung 3 dito. So you have to get 2.43. Okay, questions? I will not really dwell that much with the POH ha, kasi they have the same way of computation with that of the pH. Yeah, POH means the power of hydroxide. pH is the power of hydrogen. Most likely POH are for basic solutions. Kasi it's the power of the hydroxide. Ganon. Okay. Anything else? Kasi we will be moving on to another variable or parameter that will tell us whether the acid is like strong or weak. Okay, it's the pKa. Si pKa naman is the power of the acid dissociation constant. And we are going to compute for the pKa using this one, negative logarithm of the equilibrium constant. Okay, so wait lang. pKa class is ganito. Hindi ko na siya nasali in my PowerPoint, but we have here the formula for our pKa. pKa is the negative logarithm of the Ka. So parehas lang sila. Parehas lang sila with the pH, with the POH. It's just that kung ano yung given, again, kung ano yung given dito, yan yung hinahanap dito, class. Okay, di ba? pH is the negative logarithm of the hydrogen ion concentration. So as you can see there. And then POH is the negative logarithm of our POH. Ay, sorry. OH lang pala. Our OH. So we have OH here. OH ang given, so kaya tinawag siyang POH. This time naman, Ka means the acid dissociation constant. So remember, ito yung kino-compute natin sa equilibrium constant. Diba? Equilibrium constant is product over reactant. I hope you can still remember this. Pero sa acid, that's still product over reactant, but we call it Ka. So again, Ka is the acid dissociation constant, and it will give us class, and it will indicate whether the acid is like strong or weak. Okay, so if we're going to compute for the pKa, we will be using this formula. So, parang na-mention ko ata last time, if you have mababang pH, you will also have mababa na pKa, but you will have a large Ka. If this is the case, class, the acid is considered strong. Okay? Pagbaliktarin mo yan, mataas ang pH, mataas din yung pKa, pero mababa yung Ka, the acid is considered weak. Okay, that's how you know. Kasi all of this, class, will indicate the strength of the acid, pH, pKa, and even Ka. Okay, so let's have an example. You have here the Ka of the acid dissociation constant is 1.75 times 10 raised to the power of -5. So find the pKa. Sige daw, you try. Kasi it's the same naman, the same process with that of the pH and the POH. Pinalitan nga lang natin kasi naging pKa na siya ngayon. Sige, try nyo. Okay. While you are answering, wait lang ha. CR lang ako saglit. I'll be back. Pakisend ng answer sa chat na lang. Okay, what's the answer? $4.76. 4.75. Talaga. Sige daw. Let's see. pKa again is the negative log of our Ka. So this is pKa equals negative log of 1.75 times 10 raised to the power of negative 5. How are we going to do that in our calculator? You input negative and then log, and then 1.75 times 10 raised to the power of negative 5. 2 decimal places, pKa is 4.76. Okay, this is the correct answer, 4.76. That's the pKa. Okay, very good. And galing yung 0.10 na answer. Yung iba, nag-4 point. Saan galing yung 4.65? Paki-check kung ano yung ginawa niyo sa calculators niyo. Tapos yung iba, paki-ayos ng rounding off. Kasi it will be 4.76. Okay? Sige, check niyo yung ginawa ninyo. Okay? Questions about the pKa? Okay, magdiretso na ta. Magdiretso taan ni class. Wala? Sige. So let's have this one. Remember class, yung water ion theory natin. Di ba nagko-compute tayo nito? This one. Yung pag may binigay na OH, i-compute mo yung H. O kaya the other way around, pag binigay ang H, ito naman ang i-compute nyo. And then this, di ba this is constant, 1.0 times 10 raised to the power of negative 14. Okay, di ba yan yung last lesson natin? Last time, last week. Okay, so kapag kinompute nyo yung pKw kasi, you will have, wait lang ha, negative logarithm of the kW. So negative log of 1.0 times 10 raised to the power of negative 14. The answer here, class, is 14. Okay? 14 yan siya. Paano ko yan kinuha? pKw is negative log of the kW. So again, this is negative log of 1.0 times 10 raised to the power of negative 14. I-try nyo sa calculators nyo, you will get 14 class. Okay, that's for the pKw. So remember, di ba, pag in-negative log din natin ito ng OH, you will get the POH. And then if mag-negative log of the hydrogen ion concentration ka, you will get the pH. So pH plus POH, you will have the pKw. Kaya lang remember, this is constant. So definitely, constant din itong pKw. Kaya we will have a constant equation also. This one, pH plus POH will always be 14. Oo. Dira nakuha. Oo. So again, this will be our final formula, class. pH plus POH equals 14. So itong nasa taas is just like an explanation, an illustration saan galing si 14. Galing yan siya dito kay KW pag kinuha mo yung pKw. Okay, it's 14. So kaya pH, pag kinuha natin yung negative logarithm nilang lahat, ito na yung magiging result. pH plus POH will always be equal to 14. Therefore, If the solution is neutral, the pH will always be 7 and at the same time, the pOH will always be 7 also. So 7 plus 7, that is 14. Diyan natin nakuha yung ating pH scale class na hanggang 14. Okay, that's 1 to 14. And then dito din galing yung sinasabing pag 7 ang pH, it will always be neutral. Okay, dito siya galing sa illustration na ito. Okay, kasi gagamitin natin yan. Please take note of this formula. I just want you to remember this formula here na binox ko. pH plus pOH is equal to 14. Gagamitin natin siya dito. This one is our example, our sample problem. What is the pH of the solution given that the OH is 1.6 times 10 raised to the power of -5? Ano daw sabi? Anong hinahanap? Ang hinahanap in this problem is pH. But what is the given? The given class is OH. Again, the given is OH and that is 1.6 times 10 raised to the power of -5 formal. So as you can see, hindi ka pwedeng dumiretso kasi pH is the negative logarithm of the hydrogen ion concentration. Ang given, hindi hydrogen, OH siya. Di ba pag OH ang given, ang makukuha natin ay pOH. So this is negative logarithm of the OH class. Yan yung makukuha natin. Pero ang hinahanap ay pH. Kaya kailangan natin itong formula na ito, pH plus pOH. Anong gagawin dito sa problem? Computein nyo muna yung pOH. pOH muna tayo, negative log of the 1.6 times 10 raised to the power of -5. Ilan man na siya? Negative log of 1.6 times 10 raised to the power of -5 is 4. Ayoko, may mag-round off ha. 4.79588017. This is the pOH. Now, we are not yet done kasi pH ang hinahanap. Dito papasok yung bagong formula na pH equals the pH plus pOH equals 14. Okay? So pH class plus the computed pOH, that's 4.79588017 is equal to 14. Okay? Ito yung sinasabi ko na pwede ka mag-transfer on the opposite side kasi the operation is addition. Okay? Hindi ito division ha. Hindi mo siyang divide both sides kasi again, our operation here is addition. So what we are going to do is transpose this on the other side and gawin mo siyang negative. So this becomes pH is equal to 14 minus 4.79588017. Okay, so the pH is, let's minus this one, let's subtract, and 2 decimal places, we have here 9.20. So this is the pH of the solution now. That's 9.20. Okay? Sige ha. Anong gagawin? If OH ang given, compute ka muna ng pOH. Pag meron ka ng pOH, that's the time you can compute for the pH using this formula. Okay, that's the application. Questions? Again, the answer is 9.20. Let's have another example for you to check whether naintindihan ang gagawin. Wala. Yes, Atasha.
Ma'am, if pH good ang ginahanap, ma'am, ano gani yun, ma'am?
Pag pH ang hinahanap, dapat ang given is hydrogen ion concentration. Kasi ang partner ng pH is always hydrogen. Okay? Pero pag OH ang given, POH talaga yung mako-compute mo. Pero you can always compute for the pH using this formula. Pag meron ka ng POH. Anything else? Yes, Artea.
Ma'am, pag halimbawa ma'am gilahos na ma'am ang gihatag niya na given is katunang hydronium ion
Ion?
concentration. Pag ang dito na ni ma'am kato na da yung formula atong gamit kay na katong negative log. Mo na
Yes.
to siya ma'am.
Pag hydrogen ion or hydronium ion concentration ang given, tapos pH lang ang hinahanap, diretso ka na. Okay, diretso ka na with the pH is equal to the negative log of hydrogen ion concentration. Ginagamit lang ito kapag ka OH yung given tapos pH yung hinahanap or the other way around. What do I mean by the other way around? Kapag ka hydrogen ion concentration ang given tapos POH ang hinahanap. So sige, let us have an example of that. Wait lang ha. Mali. Sorry. Okay, so what is the pH? The POH, I mean, of a solution with a hydrogen ion concentration of 1.95 times 10 raised to the power of -4. Try nyo daw. Try nyo sundin yung previous example natin. Baliktad lang ito. Hydrogen ion ang given, tapos POH ang hinahanap. $10.29. Sige, let's see. So remember, hydrogen ion concentration ang given ha. So ang una mong i-compute, pH muna. Negative log of the hydrogen ion concentration. So this is negative log of 1.95 times 10 raised to the power of -4. So negative log of the 1.95 times 10 raised to the power of -4 is 3.70996538.9. This is the pH, but we are looking for the POH. So we need this formula. pH plus POH is equal to 14. So we have here 3.70996538 plus POH equals 14. And then we are going to transpose this on the other side. That means this will become POH is equal to 14 minus this number. This is 9,65389. 2 decimal places. POH is equal to 10.29. Okay, so this is the correct answer. It's 10.29. Okay? Saan kayo nagkamali sa computation nyo? Tama yung 10.29. Saan galing si 3.71? Or si 0.30? Anong gi-13?
Na 13 ako ma'am kay abi na ko
Round off.
result.
Ground off mo? Asa mo dapat ng ground off?
Dili ma'am kanang 14 po minus negative 13 akong na-encode sa calculator ma'am o nag 0.
Ah, okay, that is just 3.709965389. Okay, ano yung i-add? Yeah, given ang 14. This is always constant here, the 14. Given na yan siya. Okay, anything else? Questions or clarifications? Wala. Sure. Sure na.
Excuse ma'am.
Yes.
Same lang sila og process ma'am pag ang kanang pag-iba ang given gihatag ma'am basta ang second formula kay katong may addition.
Same lang process. Same lang process. pH plus POH is equal to 14. Ganun lang siya. Okay? Anything else? Wala na. So what's the importance? Why do we need to study pH? I have told you this last time. We need to study pH because pH is very important in our body, in our environment, in the things that we are using. So in the body class, our blood maintains a pH between 7.35 to 7.45. This is the normal range for our blood pH. Now, if the blood pH becomes lower than 7.35, the patient may experience acidosis. That's the name of the disease or the condition, acidosis. But if it's higher than 7.45, the condition is called alkalosis. And these two are pwede siyang mag-cause ng serious illness and pwede din siyang life-threatening, meaning it can cause death for a person. Now, why do we need to maintain that 7.35 to 7.45? Because this is the only pH range wherein our biochemicals in the body and even our tissues and organs function well. Pag nag-acidosis ka or nag-alkalosis ka, our proteins will not work. Meaning, included sa proteins, diba, yung mga hormones natin, yung mga enzymes natin, included dyan lahat sa proteins. So, hindi sila mag-work. So, syempre, maapektuhan yung normal functioning ng ating body, our tissues and our organs. Okay? So that's the reason why we really need to study pH. And at the same time, if we are going to make drugs, we have to make sure that if it is taken in the body, especially if it is like intravenous injection na diretso talaga sa blood, kailangan nating i-adjust yung pH para pareho sila ng blood ng pH and hindi siya magiging painful for the patient during the injection. And at the same time, hindi siya talagang makakapagpabago ng pH ng blood natin. Okay? So isa ito sa kino-consider natin in drug discovery or drug formulation. Even our eye preparations, yung mga ophthalmic solutions natin pinapatulo sa mata class, yung mata natin have the same pH with the blood. It's 7.35 to 7.45. And if we are going to instill eye drops class, we have to make sure that it has the same pH also with our eyes. Kasi if that is not, if hindi siya the same pH, then it will be very painful sa mata kung sino man yung papatuluan mo dyan. Okay? So, ina-adjust natin yung pH ng lahat ng ating solutions or our substances na ipapasok sa body natin. That is for the human body, ha. Now, I've said na hindi lang siya sa human body, but for our surroundings, our things in the environment is also affected with pH. Now, sa agriculture, even in agriculture class, the pH of the soil determines what kind of crop is easily grown. Okay? So just like when the soil is acidic, pag i-test nila yung soil ng isang area tapos it's acidic, ito lang yung most likely pwedeng i-grow dyan. Kasi yung ibang plants, medyo hindi maayos yung growth nila or hindi talaga sila nabubuhay. So we have here rice, coffee, banana, and pineapple. And then yung mga basic naman yung soil, they can plant these examples of plants, grapes and petchay. While pag nearly neutral, we have the corn, watermelon, the peanut, cabbage, garlic, and onion. So sino yung from South Cotabato here? What do you think is the pH of the soil there in your area? Acidic, basic, or neutral? Ano sa tingin nyo? Yung soil nyo dyan. Mga people in South Cotabato. Yeah, your soil there is acidic. Kasi as you can observe, most of your crops there are like banana, pineapple, meron ding rice, and meron ding coffee. Most likely acidic. Even sa Jensen, our soil is most likely acidic. Okay? So that is one of the reasons, class, why merong plants na maganda yung growth nila in a certain area. Tapos, ano din yung kanilang pinuproduce na fruits, like masarap din. This is one of the reasons, the pH of the soil. So before ka mag-venture into this kind of business in agriculture, you really have to take note of this thing na kailangan mo malaman muna yung pH ng soil mo bago ka mag-plant. Kasi baka nag-invest ka na tas hindi pala tutubo yung plant mo dyan in your soil. Okay, kasi it's either very acidic siya or very basic. Okay, now other than that, our products in the market like our shampoos have adjusted pH also. Most of our shampoos in the market, the pH is between 4 to 6. Pero, di ba meron tayong shampoo para sa mga babies, we call that no tears formula. Di ba? I don't know if you have heard that one in the advertisement, but no more tears o no tears formula yung sa mga baby, actually inadjust nila ang pH niyan to 7.4. So ano nga yung pH natin? Normal range, 7.35 to 7.45. So kahit paliguan mo yung baby class, tapos napunta sa mata nila yung shampoo, hindi masakit, okay? Kasi it has the same pH with their eyes. Yung sa atin, hindi talaga siya na-adjust na kagaya ng ating pH sa mata, no? Kaya kapag ka nagsha-shampoo tayo and napunta siya sa eyes natin, talagang masakit siya, class. Okay? Ano yan? Si imnon. Dili na mong hilak kung imnon. Dili mong hilak kung maadto sa mata kasi it's the same pH with their eyes. Yung sa atin kasi 4 to 6, mahapdi talaga sa mata natin yan. Kasi nga hindi the same ang pH. Now, yung production of beer, yung wine, yung vinegar, and even the cheese class, they have strict control with the pH. Kasi a change in the pH of these substances will destroy the product. Magde-degrade yung product pag hindi nasunod yung tamang pH for the product. So you will experience that one. In your pharmacognosy subject, you will experience making your own wine and making your own perfume. But yung sa wine class, you will see there that there is really a pH adjuster, a buffer na ilalagay in the wine just to prevent a change in the pH. Kasi again, a change in the pH of these products will destroy the product. Okay? Why? Okay. Bakit pH instead of the POH? Most of our materials are able to measure hydrogen ion concentration. Okay? Yung mga electrodes natin, mga pH tester natin, they are more sensitive to the hydrogen ions compared to the hydroxide ion. So that is the reason why we mostly use the pH than the POH. Diba? Wala tayong tester for the POH pero marami tayong tester for the pH. It's because of the sensitivity of this discovered na mga ways to the hydrogen ion concentration. Kaya pH talaga ang ginagamit natin. Okay? Questions other than that? Wala na. Dilipod mo gamit og ano kundi mo. Dilipod mo gamit siguro og infant na shampoo class no. Kasi the ano yung strength niyan, yung way sa paglinis niyan is really not similar to the shampoo that we use. Basig dili malimpyo yung mga ulo daghan compared sa ulo sa baby class, mas daghan jud ang hugaw sa atoa. So dili ta mo gamit ana even though na yung pH nila hindi nakakaiyak. Ano meaning ng pH? pH is the power of hydrogen. That's the meaning of the pH, power of hydrogen. Ito yun. So good. Okay, anything else? Kasi we'll take a break, 10 minutes na break, and then we will discuss indicators after. Power of hydrogen. It's the same thing with the potential of hydrogen. Synonymous naman siya sa potential or the power of hydrogen. So, okay lang. Sige, indicators. Let's talk about indicators class. In the laboratory, we identify the acidity or basicity of a substance through a lot of various of methods. So, di ba na-mention ko na, ulit-ulitin ko, we have the litmus paper, we have the pH meter strips, okay? And then we have the machine called the pH tester, which uses electrodes but is highly sensitive to hydrogen ions. Now, aside from these three, we have the so-called indicators class, okay? Yung nasabi ko, either they are classified here in the calorimetric na method or electrometric. Yung electrometric, yun yung pH tester, yung machine talaga. The rest are calorimetric. So si calorimetric, under dito or kasama dito si acid-base indicators. Ano ba yung acid-base indicators? These are actually just chemicals in the laboratory. Again, chemicals lang ito class na if you are going to combine them or add them in a solution, it will change color depending whether the solution is acidic or basic. Okay? Again, bisayaon na to. Acid-base indicators class, chemicals sa laboratory na pag inad mo siya sa isang solution, mag-change yung color niya. Pero, yung pag-change ng color niya is dependent Nag-Bisaya ba ako? English ba ako? Dependent doon kung ang substance ba ay acidic or basic. So we have here the table for our examples ng indicators. So mga tanong mo, memorize na mo na yes. The answer is always yes. So this is included sa study sa pharmacy. We always use this class sa mga tawag dyan, QC na area, quality control na area sa ating drugs or drug assay. So i-memorize talaga siya. Ang name ng indicator, yung color nila kapag nilagay sila sa acidic na environment, and ang color nila pag nilagay sila sa basic environment. But do not be overwhelmed kasi hindi naman ito mahirap. Ganito lang. Yung mga colors nila sa pangalan nila, this one. Oh wait. Let's forget about the time blue. Okay. Yung mga color sa pangalan nila, isa dyan ang color nila sa either acid or basic environment. Yung hindi lang kasali, walang color kasi sa pangalan is itong dalawa. Phenolphthalein and the thymolphthalein. So kagaya nito, cresol red, red siya sa acidic environment and ang always partner niyan class yellow. So wala naman kayong ibang i-memorize. Yung color na lang na nasa pangalan nila and then hanapin nyo lang kung saan sila magkakaroon ng color na yan and then automatic ang partner niyan on the opposite side of the fence ay yellow. Okay? So that is also true for methyl red. Sa acidic na environment, red ang color niya and automatic ang partner niya ay yellow. Nabaliktad kasi ito sa thymol blue kasi si thymol blue doon siya sa basic environment magko-color blue, but please take note, ang partner niya pa rin ay yellow. Okay? Sali ni tomorrow. Bromocresol blue, ayan, kagaya sila ng thymol blue, na sa basic environment siya magko-color blue, pero again, yellow yung partner niya. Si malachite green, okay, ang green coloration niya is nasa acidic, but ang partner niya ay yellow pa rin. Okay? So, i-check nyo lang, pag mag-memorize kayo nito, i-check nyo yung pangalan nila and then hanapin nyo kung sa acidic or sa basic ba magkakaroon ng color na yon, and then automatic, the other side will be yellow. Okay? Again, except for phenolphthalein and thymolphthalein, kasi walang color sa pangalan nila, pero yung kanilang acidic na color class is colorless. Okay? But si phenolphthalein will be color red in a basic environment and blue si thymolphthalein. So ano bang ibig sabihin yan? Example, you have phenolphthalein. Si phenolphthalein, nilagay mo siya, kuha ka ng 1 drop nito, tapos nilagay mo siya sa vinegar. Ano ba meron sa vinegar class? Ang meron sa vinegar?
Ma'am.
Acetic acid. Merong acetic acid si vinegar. So ano yung magiging color ni phenolphthalein kung ilagay natin siya sa vinegar? We have here the colorless. Okay? So the solution will stay as colorless. Pero pag si phenolphthalein class, nilagay natin doon sa sodium hydroxide solution. Diba yung mga hydroxides, basic yan sila. Pag patulo pa lang ninyo daan class sa phenolphthalein dito sa sodium hydroxide solution, mag-automatic mag-change ang color niyan into red or pink. Kapag konti lang yung concentration, medyo pink lang siya. Pero pag masyadong strong yung concentration ng ating sodium hydroxide, talagang magre-red siya. Okay? So yan yung ibig sabihin ng indicators. They will indicate whether a substance is acidic or basic. So again, what is different sa other methods? Yung other methods kasi gumagamit talaga tayo ng laboratory equipment or apparatus. This time for the indicators, we are going to use chemicals to indicate whether a substance is acidic or basic based on the change in color. Okay? Questions or clarifications? Yes. Aaron.
So nakadepende kung unsa ka food ang like ang acid or base may kadepende pud kung unsa ka kusog ang shade sa color mo.
Yes, okay. The more na concentrated yung either acid or base, the more na strong pod ang parang shade of the color. So just like phenolphthalein, if very strong yung sodium hydroxide, talagang magre-red siya. Pero if the concentration is like lowered, parang pink lang yung color niya. Faint. Faint yung kanyang color. Oo. pH talaga yung ginagamit natin instead of the POH. Okay? Sige. Any question about our indicators? I don't know if you have encountered class yung mga advertisement na yung nag-a-advertise sila ng isang product tapos they are talking about pH and then pinapakita nila sa kanilang advertisement yung parang mga change in color na sasabihin nila pag very acidic itong substance na ito, mag-change ng color. Actually, they are just using indicators. Okay, but indicators are a good way to check whether the substance is acidic or basic. Okay? Sige, now the next one will be the buffer solutions. Let me check that time. 9:12. I still have time. Okay, buffer solutions. Si buffer solutions naman, these are also chemical substances in the laboratory that we use to resist changes in pH. Okay? Masyado mahaba yung kanyang definition. But to make it simple, buffer solutions are solutions that will resist changes in pH. So for example, meron kang substance. Let me illustrate it in the screen. Meron kang substance in a beaker. Tapos gusto mo na ang pH niya ay magsistay as like acidic between 6 to 6.5. Kaya lang magdadagdag ka ng sodium hydroxide na lesser lang ang concentration, ha, example 0.1 lang. Magdagdag ka ng konting sodium hydroxide. So basically mag-change ang pH mo kasi remember this is basic and then your substance here is slightly acidic. Now, kung gusto mong hindi talaga magkakaroon ng drastic change in pH, dagdagan mo ito class ng buffer. Okay, yan yung work ng buffer. So the next time you hear the word buffer or buffer solution, please know that it is a substance that will help your solution not to change in pH kahit na magdagdag ka ng either acidic or basic substances. Okay? Yung blood natin, class, meron din tayong buffer in our blood. So sabi ko kanina, our blood maintains a pH between 7.35 to 7.45. Kapag meron tayong mga kinakain na acidic or kinakain na mga basic substances or yung hindi lang kinakain, ini-inject pa yung mga gamot na yan, most likely mga acidic or basic sila, slightly acidic or slightly basic. So bakit hindi naaapektuhan ng basta-basta yung pH ng body natin? Kasi again, we also have buffer in our body. These substances in our blood will resist the change in pH. So what are the examples of the buffers in our blood? Yung phosphate natin, the phosphate ions in our body, class, is an example of a buffer. Okay? Even our hemoglobin, yung hemoglobin natin sa red blood cells can act as buffer. Our proteins are also buffers. And at the same time, the carbonic acid. Carbonic acid bicarbonate ions are also buffers in the blood. So marami masyado tayong buffer in our body. That is the reason why even if we eat something, hindi basta-bastang nag-change yung pH ng ating blood. Okay? Now, in our pharmaceutical world, let's get away from the body. Pharmaceutical world, let's talk about drugs. Yung mga drugs din natin, class, most of them contains buffer. Kasi whatever happens to them in the environment, if they are already out in the market, tapos may mga like mga contamination or changes in the temperature in the environment, pwede kasing ma-change yung pH niyan, either tataas or magdadrop yung pH. So before that na mag-happen, no, nilalagyan na nila ng buffer. Kasi remember, the change in pH in our pharmaceutical products would mean degradation of that product. Masisira yung product natin. So nilalagyan na nila ng buffer. Okay? So I don't know if you're fond of reading ingredients of the products that you use, but even cosmetics class contain buffer. Pag babasahin mo yung mga ingredients natin, like sa mga cosmetic products natin, marami masyadong ingredient. Hindi nga lang naka-identify talaga na ito, buffer ito. But if you're going to evaluate one by one, the roles of those chemicals in your cosmetic products, makikita nyo na isa or dalawa dyan ay buffer solutions, okay? Or buffer chemicals, just to resist changes in the pH to avoid degradation of our product. So ano ba yung content ng mga buffer solutions natin? Buffer solutions class contain either a weak acid and its salt or a weak base and its salt. So it's a mixture. Take note, buffer solutions are mixtures. And ano yung content? Pwede siyang weak acid plus yung salt niya o kaya weak base and yung salt niya din. Ito yung examples class. Acetic acid is a weak acid. Pag hinalo mo siya sa kanyang salt, the salt is called sodium acetate. Pag naghalo yan silang dalawa, pwede silang gamitin as buffer solution. Okay? So this is for the weak acid and its salt. Ito naman is for the weak base and its salt. Ammonia water is a weak base and ito yung kanyang salt, ammonium chloride. Okay? So how do you know it's a salt? A salt class contains a positive and negatively charged component. So lahat ng may positive at negative charge component, salt yun siya ha. So just like this one, sodium is positive 1, acetate is CH3, COO negative. So may positive and negative component siya. Si acetic acid kasi class, wala. Ganyan lang talaga. CH3, COOH. And then we have, although meron yan siyang, meron yan siyang charges dyan sa mga elements niya, pero it's an acid. Ito naman is a base. Okay, ito yung kanyang salt. Ammonium, remember, contains ions. So ito na lang, para maging salt siya, may ions siya, positive and negative. So cations and anion. So positive 1 and negative 1. So again, pag minix natin together silang dalawa, pwede natin gamitin as buffer. Okay? So everything will end in computation class. So meron tayong tinatawag na Henderson-Hasselbalch equation. This is actually our buffer equation para ma-check natin yung pH ng ating buffer solution class. Now we have two kasi 'di ba depende sa buffer na gagamitin. Pag acid yung buffer class, use this formula to compute for the pH of that buffer solution. pH is equal to pKa plus logarithm of the concentration of the salt divided by concentration of the acid. Yeah, depende sa indicator. Oo. And then pH is equal to pKa plus log of the concentration of base divided by the concentration of salt. Yes, Lauren?
Wala nang negative yung log, ma'am.
Wala na
Positive
negative.
lang.
Walang negative yung log dito. Talagang pKa plus log of the salt divided by the acid. But please take note ha of the difference in the formula. Kasi kapag ka-acid yung substance, salt sa taas, acid sa baba. Pero pag basic yung buffer, base sa taas, salt sa ilalim. So we have this example. What is the pH of the solution containing 1.3 molar acetic acid and 0.9 molar sodium acetate? The pKa of the solution is 6.8. So let's try to compute for the pH of the resulting buffer solution. Again, pH is equal to pKa plus logarithm of, remember, acetic acid ang ginamit, so we will be using this formula. Concentration of salt divided by concentration of the acid. So let's check the given. Yes, we have the pKa. And alin yung concentration ng salt? Diba the salt is the sodium acetate. So this is the concentration of the salt. And syempre acetic acid is the acid. This is its concentration. So let's substitute this one to compute for the pH. pKa is 6.8 plus log of what is the acid? The salt pala, 0.9. Sa ilalim is 1.3. Hindi ko nilagay yung unit. Walang unit naman ang pH. Okay, so this is 6.8 plus log of 0.9 divided by 1.3. 0.9 divided by 1.3 is 0.69230762. Tapos 6.8 plus, let's get the logarithm of the 0.69230762. So log of that is negative 0.159700842. Negative yan ha. So the pH is 6.8 plus negative 0.159700842 is 6.64. So this is the answer. pH is again 6.64. Okay. Ano, 6.76 man na nag-round off mo, no? Class, do not round off during the process, ha? Mag-round off kayo during the final answer na. Okay, so we'll have a more accurate na result, and that is 6.64. Sige, diretso tong tatlo. So again, that's 6.64. Do you have questions? Ano lang ha, i-substitute nyo yung values dyan. Okay, so how about this one? What is the pKa of the solution with 0.6 molar ammonium chloride and 1.13 molar ammonia water? The pH is 8.1. Try nyo daw i-submit. Time pa ba ako? Oh, it's already 9:24. Let's have this one. This one is the end. Gawin ko na itong assignment sa inyo and then we'll check tomorrow. So 1/4 na lang ipasa nyo. And then may assignment pala ako na parang hindi ko ata nalagyan ng submission bin. Pero lagyan ko siya ngayon. Yung remaining na, yung sa assignment natin sa computation. I cannot remember if I made a submission bin for it. But anyway, this will become your assignment, class 1/4. Please pass it tomorrow during our class. Na kasi this is the end of the slide. So ano na lang, before we'll end, I'll discuss na lang this one, ionization of weak polyprotic acids. Pag sinabing polyprotic means marami siyang hydrogen. So pag aprotic, meaning no hydrogen. Tapos pag monoprotic, syempre, isang hydrogen. Example ng monoprotic is hydrochloric acid. Diba? Meron siyang isang hydrogen. And another one, nitric acid, isang hydrogen din. And then pag diprotic, syempre, tatlo. Ay, tatlo. Dalawa. Phosphoric acid tinignan ko. Diprotic is dalawa. So example of this is sulfuric acid. Okay, you have H2SO4. Dalawang hydrogen yan siya. Now, we have polyprotic if marami na siya, 3 or more na yung kanyang acid. So just like the phosphoric acid. So mag-ionize yan siya. This one is considered a strong acid kasi talagang i-release niya lahat ng hydrogen niya kahit tatlo pa yan. So magre-react yan siya with water to produce this one and the hydronium ion. Okay? And then this is hydrogen phosphate. Dihydrogen phosphate. And then, yung dihydrogen phosphate na nabuo will react with another molecule ng water kasi syempre pag nasa tubig, maraming molecule ng water yon. So yung succeeding na product will react again with another molecule of water to produce hydrogen phosphate. And then yung hydrogen phosphate will also react with another molecule of water to give the phosphate ion. So this is the phosphate ion ha. But nevertheless, all of the hydrogens of the phosphoric acid are being released in water. So this is how a polyprotic acid ionize. Okay? That is also true actually for diprotic and monoprotic acids. Lahat ng hydrogen nila, i-release yun nila. Okay? Just want you to know what's the meaning of the polyprotic acid. Then again, assignment nyo ito for tomorrow. And then we will try to compute that tomorrow also. Okay, kasi dyan tayo mag-end. So I'm done with chapter 2. This is the end of the slide. If I still have time, after the intrams, I'll be adding another chapter. Pero I don't think I can finish it. But nevertheless, magsa-start ako ng another slide. I-post ko to afterwards, the recorded discussion. Sige. Wala ba na ako naghihatag ang copy? Pero nagbigay na ako ng copy ng PPT neto. Yung video na lang, yung recorded discussion na lang, i-upload ko. Okay? Any question or clarification before tayo mag-end? Yes, Artea.
Excuse ma'am, lab o lecture atong i-quiz ugma ma'am.
A short quiz in the lecture yung diniscuss ko lang ngayon. Tapos, wait lang. Sa laboratory, it will be activity number 4. So get ready with your calculators tomorrow. Ha, walay mabilin nga calculator kay mag-mental math yun mo tomorrow. O yung assignment pala, hindi ko pala talaga nalagyan ng submission bin. Lagyan ko ng submission bin ngayon.